All right, here's our next example. I have e raised to the power of 3x plus 1 is equal to 4 raised to the power of 2x. Again, this is an exponential equation, so we're going to solve this by, Dr. Guffey used to say, hit him with a log. So hit log of the left is equal to the log of the right. Now, on the left-hand side, these cancel. You're left with just the 3x plus 1. You said, now why doesn't they cancel over here? Because this in order for these to cancel, this must be e, not some other value. So the natural log of e, those are the inverse functions. The natural log of 4 is just some weird constant. So the natural log of e, that cancels. And so this, on the left-hand side, you're left with just the 3x plus 1. On the right-hand side, you must actually apply the property of logarithms, which says this comes down front of the logarithm. This becomes 2x times the natural log of 4. Now, this equation is different from the previous couple of examples. What makes this different is there are x's on both sides of the equation. What I'm going to show you here is a technique that's good for this. There are also some specific places in Calc 1 where this arises in a different context, but knowing how this works is a good skill to have. So what we're going to do is this. All the terms, we have 1, 2, 3. In this case, there are 3 terms in this equation. All the terms that have an x in them move to the left-hand side. All the terms that do not have an x in them move to the right-hand side. So, 3x has an x, it stays on the left-hand side. Plus 1 does not have an x in it. It needs to get moved to the right-hand side of the equation. And of course, if you add 1 in order to move it across, what's the old thing? When you cross the line, you change the sign, or however you learned that. And then 2x, this term has an x in it. It must go to the left-hand side. All the x's go to the left. All the non-x's go to the right. And so, if you reshuffle everything, 3x stays where it is, so nothing happens to it. This 1 needs to go to the other side of the equation. When you move the 1 across, it becomes a negative 1. And what happens to this expression when we move it to the other side of the equation? We have to subtract it across. It becomes negative 2x natural log of 4. So all the x terms are on the left, all the non-x terms are on the right. What you then do, once you have all the x's gathered, all the non-x's gathered, then factor out the x. Factor the x out of this expression. So factor out the x. Well, if you factor an x out of here, the question is, what do you leave behind? Well, you leave behind the 3 and the minus 2 log 4. Leave behind the 3 and the minus 2 log 4. So this is 3 minus 2 log 4. On the right-hand side, do nothing. That's still equal to negative 1. So what we have now is x times this crud. This is just one great big constant. X times a constant is equal to something. Divide both sides of the equation by this big ugly constant. And so everybody gets divided by 3 minus 2 log 4. So what does that look like? That becomes x is now equal to, here it cancels. This is equal to a great big fraction, negative 1 over 3 minus 2 natural log of 4. That's a 4. And that's the exact solution. And if we want a decimal approximation, again, what I would do is put this in parentheses and put this in parentheses. So what we have is, I'm going to say open parenthesis, negative 1, and then close that, and then divide by open parenthesis 3 minus 2 times natural log of 4, close, close. And I have negative 4.397. I'm going to say this is approximately negative 4.40. That is a brutal approximation, but that's the value I could approximately get for that. So, if you have x's on both sides of the equation, once you clear the exponentials out, When you have x's on both sides of the equation, all the x terms go to the left, all the non-x terms go to the right. Factor out the x and divide this garbage, and you'll generate the solution that you need.